So in this extended tutorial, we are going to be looking at some more advanced configuration features in order to improve the security and performance of our network. We're going to start with configuring static routing. So if we click on one of our routers and go to config, at the moment we're using before I go any further, let's just iterate that you have to have everything working exactly as in the previous tutorial in order to guarantee that everything's going to work the same as it is here. If you've changed your addressing structure in any way, um, naming scheme, then you need to adjust for that as well, so that you don't just follow what I'm doing without looking at your own work. So with that disclaimer, we're going to move on to the router. We're going to go to RIP. So at the moment we are using something called dynamic routing, which essentially means that any address from this particular network can be routed through to this network. So there's two issues with this. It can waste a lot of time searching or um, uh, looking up routing tables to find out whether the address is there. So we're going to use something called static routing, which is basically manually setting specific addresses that we want to route, and they use the term hopping, so hopping from one network to another one. So we're going to delete these, and we're going to go over to static, and we are going to, so it might be slightly counterintuitive to what you think you should do here. So we're going to, when it asks the network, it's not asking for the network that we are currently on, which is the 192.168.0. So that's this network. We want to route over to this network over here through this middle network here. So if I keep that down there, so we've got network, one we want to reach is 172.16.0.0. The mask 255.255.0.0. Yeah, network and host addresses. The next hop, so we are here. We're going to get there by hopping from this router to this router IP address, yeah, which is 10.0.0.22. So you're going to reach this address space by hopping via this point here. So 10.0.0.2. So you can see that not only does this increase performance in terms of just directing the addresses that we need, it also improves security, because if you have dynamic routing, then you can have basically any person on that network can go through the router. So we can add that there. So we're going to 172.16 via 10.0.2, and then obviously we need to do that the other way. So let's delete and go to static. So we're hopping the other way. So we're going to 192.168.0.0 mask 255.255.255.0. Next hop, so we're going from this router, we're hopping over this way and that's going to be 10.0.001 add, and then we check to make sure that we can go, that we have not broken anything. So that should be ping 192.168.0.254, I believe it is. That's our remote PC down here. So going from our wireless laptop. So again, it timed out the first time because as in real life, it takes a little time for things to sort of work themselves out. So we've now done the static routing, and we're going to look at configuring some firewall settings. So firewall obviously improves the security. We're also going to block out certain computers that might be used by customers. So I suppose you could say that it helps with the ease of use of those devices as well. And any kind of controlling and directing of the correct kind of traffic will also improve performance overall, so you don't have an unwanted traffic and interruptions. So we're going to the server. So we're going now. What I show you can then be applied to any other device. We're going to do the server because the server might obviously be the location of the most sensitive information that we might be using, and where excuse me, attackers might target. So we go over to desktop and we click on firewall. So at the moment it is off, and so we're going to turn it on, and we are going to start with allow. So remember, by default everything is allowed. If we allow something specific, then by default everything else should be disallowed. So we allow, and I'm going to allow IP, and we're going to allow the current network that we are on. So 172.16 not going to matter for the other two because we are going to do. So remember, this is the reverse mask. So we put the zeros for the addresses that we want to keep the same. So we're not interested in those. We're interested in the last two. So we want to say that any of those can be changed, and we're going to allow. Obviously, you can see there's a deny, yeah, but if you deny from this point of view, you would have to deny individual things, whereas I can allow, deny everything else, and then if you work with it, it does make sense. So anyway, so 172.16, and I am going to allow all of the devices on that network. So add. Let's test that out. So let's go back to our laptop. And we are going to 172.168, no, 16.0. Right, so our server is number 10, and so I have no problem connecting there. Let's try our remote desktop. So theoretically, we shouldn't be able to make contact because we have not been allowed. So as soon as the firewall is is turned on and starts allowing traffic, everything else then becomes denied. So it's an instant sort of security feature. However, this is obviously our proposed branch office. Might be a different network, but we want to allow that network as well. But we're going to only allow that certain device. So we're going to start with a new set of rules. So 192.168.0 point. Now I could allow every device on that network. But there might be I might want to stop someone from plugging something in on that network and then being able to access my server, or whatever the situation might be. But this is to show that we can specify certain devices. So if I put all zeros for the wildcard mask, it's now saying that none of these numbers can be changed. I am directly pointing towards this particular IP address, and I'm going to allow that. So any other device on that network. So we'll contest. Let's see if we can test the printer. let's add that, sorry, rather than save over the other ones. We've got two different rules. Let's just have a check. No, you can't. There's no command interface on there. Some printers you might be able to. So you could stop, for example, someone being able to only allow end devices, and any other device would be blocked. So we can go into the command interface of this computer, and we're now going to ping exactly the same device, and we should be allowed, which we are. So we're now allowed into the firewall, or past the firewall in that case. One last thing that I can do, sort of show how these things work, is say, for example, my laptops are in the lobby and I'm using them to help the customers can browse or whatever it is that they're doing on there, and so I want to block them specifically. So if I remember correctly, just go in and check that. If we go to services, DHCP, so we are only allowing DHCP on the laptops, so we're only enabling them on the laptops, and we started with the address on hosts 5, so anything 5 and above. So I could actually block specific parts of the host space rather than all of the hosts on that network. So we're going to click on this rule. And we're going to change this 255 in the wildcard mask here to 0. So I'm now saying that 172.16 and 0 must be cannot be changed. Okay, so that means then that 5, anything 5 and above, is not going to be included in this rule. So only the first 250 of devices are going to be allowed. So if I save this rule and then click on our laptop, go to command prompt. So we're now going to try and ping this server from this customer facing laptop, and we are not allowed. Let's just check that we're allowed. from our sort of staff PCs. Ping 172.16.0.10. Yeah, so we can specify exactly who is accessing what device from where. And that concludes our extended tutorial. Thank you.